Good day, folks. Our objective for today is we are going to find the sum of an arithmetic sequence. And when you're all done today, you'll be able to do a problem like what I've shown here in the do. All right, now I want to really quickly refresh a little bit of what we did last time. We told the stories of Frederick Gauss. Now, in telling the story of Frederick Gauss, just to recount the story a little bit, his teacher set him aside, and he had to count up the numbers between 1 and 100, and he came back, and of course let's just remember the formula he came up with from that story. Remember, if we take from k equals 1 to any n value of k, that was equal to n times n plus 1 all over 2. Okay, so that was the formula that Frederick Gauss came up with here from the story that we talked about in class. Now, what I want to do here is let's take a look at this formula that we have right down here. And let me show how this formula here goes down into that formula there. Now, the way that happens is we're going to find the sum of any arithmetic series of the first n terms of the sequence. Okay, so that tells us that this term right here is going to be the first term of the sequence, and this is going to be the nth term of the sequence. Okay, and of course I have n terms in the sequence. Okay, so what we're going to do is let's first of all bring that 2 out front, and I'm going to write it as n over 2. All right, now remember what I said. This is going to be our first number in the sequence, and this is going to be our last number of the sequence. Okay, so that gives me a sub 1 plus a sub n. All right, and that is how we come up with that. All right, let's just real quickly review what the difference between a series and an arithmetic series is. Okay, well, first of all, a series is this right here. It is the indicated sum of the terms of a sequence. Okay, we all know that. We studied that in section 12.2. But what is an arithmetic series? Well, remember what an arithmetic sequence was. An arithmetic sequence had a common difference between each. Well, an arithmetic series then is simply just the sum of an arithmetic sequence. Okay, so there you go. Go ahead and pause the video, get that in your notes. All right, now let's do an example of that using that formula. So now remember what the formula was. We had S sub n is equal to n over 2 times a sub 1 plus a sub n. Now, anytime you're working these, what I want you to do is I want you to write down the pieces parts of this formula off to the side, and we're going to look at the problem and see if we can identify, oops, that was a sub n, see if we can identify each of these pieces. All right, so first of all, in looking at this, we know that a sub 1 is 12, so we're going to put a 12 there. I know that a sub n is 100. I know that 12 is my n value. Okay, so now in looking at that, we need to find what S sub n is. That's going to be our unknown. Okay, so what are we actually finding? Well, let's take a look at that so we can see. We know our first number in our sequence is 12. I know that my last number of my sequence is 100. And I know that my n value is 12. In other words, that tells me that a sub n is 12. All right, so let me write this out. I know that my first number in my sequence here is 12. And I know that my 12th number of my sequence is 100. And I want to know what is the sum of all of these together. Okay, so that's what I'm trying to find. So let's go ahead and do that here. So we have S sub n is equal to, we have 12 over 2 times the first one, which is 12, plus the last one, which is 100, and then we're going to work this out. Okay, so S sub n is going to be equal to, I have 12 over 2, and then that gives me times 112. Now, let's just plug that into our calculator. And that tells me that the sum of the first 12 numbers of that sequence is going to be 118. Okay, so there it is. For our next type of problem, what we're asked to do is find the sum of the first 60 terms, of which the first one is 15, and we don't know the last one, but we know the common difference is 80. Now you could write down 50, add 80, and keep doing that until you get all 60 of them listed out and then add them up. But that's a long way to do that. But I wonder if there's a way that we could come up with a formula to help us derive what that is. And it turns out there is. What we're going to do is we're going to use this formula right here. Remember, this is the formula for an arithmetic sequence. And notice it's equal to a sub n. I'm going to take that and I'm going to plug it into the formula we just derived, or the one that Frederick Gauss kind of derived, and we're going to come up with a different formula in order to take care of this situation. Alright, so let's go ahead and play with that here just for a little bit here. So if I take this here, and I'm going to have s sub n is equal to, you have n over 2, and then I have a plus 1, and I'm going to plug that in, so I have a sub 1 plus, then I have n minus 1 times d. Now here, looking at this, I see that I have two like terms right there. I'm going to add those two like terms together. So s sub n is equal to n over 2, and then I get a 2a sub 1 plus the quantity n minus 1 times d. And this will give us the formula that we can do in order to solve this new scenario type of problem. So in your notes, go ahead and write down its formula, and be sure to write down the derivation of it too, because that would be a great test question for a note quiz. Now, we are going to use this formula when the last term is unknown. Now, on the left side of your Cornell notes, I want you to make a note. We will use this formula when the last term is unknown. Now, when are we going to use the formula that we generated first? Well, guys, look at what we don't have. Right now, we know the d, but before, I did not know the d. So if you don't know the d, you use the other formula. And if you do know the d and you don't know the last term, then we're going to use this formula. Okay, so make those notes in your Cornell notes so we know when to use which type of formula. Okay, let's take a look at some more examples here. Now, notice here, guys, I want you to see something. Okay, this problem right here, we've already worked this problem here. What formula did we use with it? Well, in case I wasn't very clear, we used the first formula that we derived. Okay, so we're going to use that formula. Why? Because we know the last term. Okay, you see that? We know the last term. Look over here. Do you see an a sub n there? Nope, you sure don't. But what do you see? Well, you see the common difference. Do you see the common difference over here? Nope, I sure don't. But I do here. So that means I am going to use this formula right here. This one right here when I know the d value. And I'm going to use the other formula when I don't have the d value, but I do have the last term. Okay, so let's go ahead and see if we can practice this one a little bit and see just how this one's all going to work out. Okay, so the first things first, I know which formula I'm going to use. So since I know the formula, I'm going to write down the parts of that. So first of all, we have s sub n, I have n, I have a sub 1, and I have d. Okay, so let's write down each of those parts. Okay, s sub n, I don't know. A sub 1 is 42. N is 8, and d is 6. Now, we're just going to plug those parts right up into there. So I have s sub n is equal to, our n value is an 8, over top of 2, times the quantity, 2 times my a value, which is a 42, plus, then I have my n again, which was 8, so that'd be 8 minus 1 times my common difference, which was 6. All right, now we're going to enter that into our calculator and see just how that's going to look. And let's see how that is going to look. Well, let's see. The first thing I'm going to do, so a sub n is going to be equal to, that's going to be a 4, 8 divided by 4. Now, normally I want to do what's inside the parentheses first, but with that 8 over 2 stuck out in the very beginning, I just went ahead and simplified it. Now, looking here, first thing I want to do is I want to do inside parentheses. So right there. So I am going to go ahead, and that gives me 2 times a 42 plus a 7 times a 6. Well, a 7 times a 6 is 42, and a 2 times a 42 is going to be 84. Okay, then we're going to times that by 4. Let's see, 84 plus 42 gives us 100 and what? Think with me. 126. Double check me, make sure I'm right. Times a 4. And if you take that 4 times it by 126, real quickly plug it into your calculator, what do you come up with? Yes, yep, I agree, 504. So what does that mean? Well, if the first term in the sequence is 42, and you have 8 terms, so there's the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, the seventh one, and the 8th one, and you added the 6 and got the next term, and so on and so forth, and then you added each of these together, this one, 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 and this one, you would come up with 504. All right, guys, that's what that means. Okay, let's take a few moments and let's just review what sigma notation meant. Sigma notation, remember the sigma, it means that the sum of the numbers from k to n. Okay, so k equals 1 to 10. So you're doing the first 10 terms, starting with term 1, going to 10. You're adding all those up, you're plugging it into this formula here. So let's come up with just what we're going to do right here real quickly. If I want to find the first term, I am going to plug in this 1 right there in for that k, so it'd be 2 times 1, okay, 2 times 1, which is 2. Okay, next I plug in 2. 2 times 2 is 4. Then I plug in 2 times 3 is 6. And I go all the way down to 2 times 10, which is 20. So then I'm going to add all of those up. So we're going to take 2 plus 4 plus 6 plus ... plus all the way to the 10th one, and you're going to add each of those up. Okay, now, how many terms are there going to be in this one here? Well, how many? Well, 1, 2, 3, 4, 5, 6, 7, all the way to what? 10, yes. So, there are going to be 10 of them. Now, what formula do we need to use to find this? Well, what do we know? Well, think about it, folks. Think about it. Do we know the first term? Yep. Do I know the last term? Yep. Do I know the n value? Yep. So what formula are we going to use? If you said the first one we learned today, which is this one, you are correct. Okay, good job. Now let's go do another problem or two, and then we're going to wrap this up for today. Okay, now this problem is a little bit different. So I'm asking myself, what am I going to use? Well, can I come up with the first term? Yeah, I just plug it in. Could I come up with the last term, the 20th? Yep, I just plug it in. Okay, so if I can come up with the first term, and I can come up with the last term, and do I know how much n is? Well, how many numbers are there from between 1 and 20? 20. Okay, so what does that tell you? We are going to use this formula right here. So S sub n is equal to n over 2 times a sub 1 plus a sub n. All right, now, so I have to know what is S sub n, what is n, what is a sub 1, what is a sub n. Now, notice I'm patterning this. I'm doing this way to give you an example of how you can follow when you do each of these questions here. All right, so what is my S sub n? Well, we don't know. That's what we're trying to find. Okay, how many numbers are there? Well, I'm going from what? 1 to 20, so that means my n value must be a 20. Okay, so what is my a sub 1? Well, I just plug 1 in there. Okay, so that gives me 2 times 1 plus 1, which gives me how much? 3. That's right. Now, let's find out, how do I find the last one, the 20th one? Well, I plug this 20 into there. Okay, so it's going to be 2 times 20 plus 1, which gives us how much? 41. That's right. So now we just plug that into our formula. So S sub n is equal to, it's going to be 20 over 2 times the first term, which is 3, plus the last term, the 20th term, which is 41. Now, we plug that into our calculator here. Let's see, I'm going to get, well, we don't even need to use a calculator. It's too easy here. 41 plus 3, which is 44. Now, 20 divided by 2, which is 10. And 10 times 44 is going to be what? 440. So, what does that tell us? The sum of the first 20 terms of this series is 440. Excellent, guys. All right, let's go try another one. Now, for this next one, I think I just want to kind of set it up, and I'm going to let you finish it. So, make sure you finish it, so then in your Cornell notes, you'll have it in case we ask you some questions on it. Okay, so what does it say first of all? The first 50 positive odd integers. All right, so I know there's how many of them? Well, 50. Okay, so what's my n value? Well, it's going to be 50. Now, do I know s sub n? Well, no, that's what we're asked to find. Okay, do I know a sub 1? And do I know a sub n? Well, it says find the first 50 positive odd integers. So the first one is going to be what? Well, think with me here. 1, 3, 5, 7, 9, and so on and so forth. So the first one is going to be what? 1. Yes. Now, if you may think that it's just going to be 1 to 49, but don't make a mistake. That's only half of them. You have to go clear to almost 100 because you're taking every other number, which means it's going to be 99. And then you just plug that in. Okay, so your job, guys, is to go ahead and finish this problem out and have that sum ready for me in class next time. And by the way, I may ask you at the door for that sum. So be sure to work that up. And you never know, it just may be worth 5 points for you if I can see it as you walk in the door. So have it on a piece of paper, hold it up there as I walk in the door. I just might give you 5 points for it. Okay, let's move on. This is our last problem for today, and it's a little bit different. First of all, it says find the first 3 terms of each arithmetic series. In other words, I am going to give you the sum, and I'm going to give you the last number, and I'm going to give you the first number, and your job is to come up with the first 3 terms of it. Now, I didn't give you the common D. Didn't give you that common difference. Okay, so what are we going to do first of all to do this one? Well, let's just kind of think outside the box. Let's think of our 2 formulas. First of all, we have S sub n is equal to n over 2 times the first one plus the last one. Okay, and secondly, we know that S sub n is equal to n over 2 times, and it's going to be 2 times the first one plus n minus 1 times the common difference. All right, so looking at this first of all, let's see. Well, let's see. I can take this number here and I can plug it in there. We can take this number here and I can plug it in there. Okay, I have the first here and I can put it there. And guess what? I have this, this, and this, so I have one equation with one unknown. I can solve that. Okay, so let's go ahead and do that. So we're going to have 900 is equal to n over 2 times 7 plus 83. Now, 7 plus 83 gives us 90. Okay, then right here, I'm going to kind of push you a little bit to do it in your head. So we have 90 times n divided by 2. So that would be the same as what? Well, 900 is equal to n over, and what's 90 divided by 2? 45. Okay, so let me squeeze that in there a little bit here. So we're just going to put 45 times n. Now we're going to divide both sides by 45, and I get n is going to equal, okay, punch that into your calculator. What does it give you? Well, guys, I get 20. All right, now let's see what we know now. All right, I know the last number in the sequence. I know the first number in the sequence, I know the sum, and I know the n value. Okay, so I know this number, I know that number now, I know this number, and I know that number, and I don't know that. So guess what? Again, I have one equation with one unknown. So now I'm going to take this here along with these numbers up here, well, the ones that are applicable anyway, and I'm going to plug it into this formula. All right, now don't let me lose you. Stay with me. Okay, so let's go ahead. We're going to plug 900 in for S of n is equal to, n is 20, so it's going to be 20 over 2 times 2 times the first, that is going to be 7, plus my n value, which we already know to be, make that a plus sign here, which is a 20 minus 1 times d. Okay? All right, now let's just simplify that. Order of operation tells me I want to take care of this first. All right, so let's go ahead and do that. So let's see, I have 900 is equal to, you know what, I'm going to go ahead and take 20 divided by 2 because it's out front. Okay, and I'm going to go ahead and multiply this 2 and 7, gives you 14. We can do that. Plus, and then I'm going to get 19 times d. Okay, now guys, hope I didn't lose you, but you know, there's just a few little tactics that you can use to simplify this. So don't let me lose you. Now, next I'm going to unwrap this equation. Okay, so I could distribute this in right here first, but I don't think I want to. What if I were to divide both sides by 10 instead of distribute it in? That would save us a few steps. So I'm going to divide this side by 10, divide this by 10, and I get what? Well, I get 90 is equal to 14 plus 19 times d. All right, now I'm going to subtract 14 to both sides, subtract 14 to both sides, and I end up getting 76 equals 19d. Divide everything by 19, and I get d is equal to a 4. That tells us that my common difference is 4. So, what is it going to be? Well, let's go ahead and write it out. Okay, we knew the first term was going to be 7. So I'm going to add 4 to it, and I get 11. Then I add 4 to it again, and I get 15. So, there are my first 3 terms of that sequence. Okay, we're going to stop there for today. So let's go ahead and let me show you what the assignment is going to be. Okay, folks, that's going to wrap it up for today. When you come into class, next class period, what do you need to have for me? If you said that one problem all worked out, yes, that's right. So have it on a sheet of paper, have it as you walk in the door, and it may be worth a couple points to you. Okay, now, when you come into class, we are going to do a worksheet, and we're going to practice a few more of these type of problems in order to get real good at finding their arithmetic series. All right, guys. Well, you have a super great day, and I will see you in class.